Hi, hello, good evening, one and all. Welcome to the session. Can anybody confirm about audio and video? Hi, guys, hello, welcome to the BYJU'S exam prep. Please do let me know about audio and video so that we can move on to the session. तो आज का सेशन में हम प्रीवियस ईयर क्वेश्चन डिस्कस करने वाला है that were asked in 2002 and 2008 2016. These are the years, in these years IISC Bangalore has conducted the exam. So I have taken or I picked some questions from 2002, 2008 and 2016. So try to get the use of this session and this, if you look at these questions, you will get an idea in what way they are going to ask the question and how you need to answer them. It's not like most of the questions are tough or most of the questions are easy. It's like always the question paper will be always easy, moderate and tough. It's very rare to get the question paper mostly more likely to be easy. Okay, so it's like always the questions will be mixture of easy, moderate and tough. Tough means it just takes time. I want to say tough means tough doesn't mean that it's very difficult to solve. The only thing is I can say that it takes time to solve the question, and easy it takes less time to solve. It takes less time to solve, and moderate maybe it takes greater than 1 minute or less than 2 minutes, and tough question will take more than 2 minutes, like that. Okay, so please let me know your presence, and we'll move on to the session very quickly. Come on, guys. So I'll start the session. Before moving on to the session, there's a small introduction about myself. My name is Naveen Gollapalli. I have 11 plus years of experience in teaching. I did my masters in electric power systems from JNTU Hyderabad. I cracked GATE and State Public Service Commission examinations too. I taught more than 20,000 students since 2012. Most of the times I'll be taking electric circuits, machines, measurements and power systems. Okay, so this is my small introduction, right? So moving on, there is a small, what I can say, Telegram channel. The small announcement about my, Telegram channel. If you have any doubts or if you have any, if you want any help, you can contact me on this Telegram channel. You can join here so that you will get some questions based on the concepts and some important questions. I'll be posting some. If you want any study material, I'll try to post the study materials. If you want any textbooks, I'll try to post the textbooks too. Okay, PDFs. And even if you want any classroom, that means what if this session is going right, so after this session I'll try to share the PDF of this session so that you can get the entire questions and answers at one point. Okay, the main thing is here, if you have any doubts you can reach me on this. If you have any doubts you can reach me on this so that I'll try to respond and I'll try to clear your doubts. Okay, all right. There is a announcement from the BYJU'S exam prep platform that US Union Public Service Commission is going to conduct engineering service examination every year, right? So that results came, mains results came, prelims and which is generally used to happen in January February month, and you will be expecting the results in the month of April May, and then later the exam will be conducted on July August, like that. Okay, so the results are out, and now the people are preparing for interview. Okay, interview, right? If you want any interview guidance, then reach out to us. We will definitely help you to crack your examination. Okay, all right. Tell me now if you have, If you have any doubts, please comment your doubts in the comment box, and I'll try to take up your general doubts also. Okay. So within small time, within 1 or 2 minutes, we'll try to start the session. Okay. Please do join in and share this session with your friends also. All right. Chalo. Moving on to the next thing, let us take up the questions. Let us take up the questions here. This is a question which asked in 2002 and asked for 2 marks. The question is about transformer. He has given some 3-winding transformer with a voltage ratings of 400, 200, 200. 50 Hz 3-winding transformer is connected as shown in the figure. Alright. So he has given the figure here, and the connection is like this. The connection is like this. Okay. What is asking? He is asking the reading of the voltmeter will be. The reading of the voltmeter will be. So here is the voltmeter which is connected at this terminal and at this terminal. Okay. He is asking for voltmeter reading. Simply voltmeter gives what? Simply summation of voltages or subtraction of voltages, right? You start from here and end again here. You write a KVL. Dot generally represents positive polarity and undot represents the negative polarity. So you can take up negative, negative, negative. Now if you move from here, this is of 400 volts and this is of 200 volts and this is of 200 volts. So if you move from here, the marked terminal, if you move from here to here, this point is 400 volts, and then if you move from here to here, this point is minus 200 and this point is plus 200. Okay, so I am getting plus 400, minus 200, minus 200. Alright, and I am reaching this terminal. So the voltmeter reading minus Vm or minus V is equals to 0. So you will get V is equals to E is equal to 400 minus 200. Oh, sorry, this is plus, the leaving polarity is plus. Minus 200 plus 200, it will be 400 only. So minus 200 plus 200 gets cancelled, and you'll be getting only 400 volts. Okay, right. So this is the voltage which can be read by the voltmeter. Let us go through next question. Here is a question which is asked on again single phase transformer. The single phase transformer rating is 1 kVA, 230 volts, 100 volts single phase 50 Hz transformer, having negligible winding resistance and leakage inductance, is operating under saturation. While 250 volts 50 Hz supply, sinusoidal supply is connected to the high voltage winding, a resistive load is connected to the low voltage winding, which draws the rated current. Which one of the following quantities will not be sinusoidal? Will not be sinusoidal. So he is saying that the core is saturated. That means what? Harmonics is there. Harmonics are there. Now if it is a single phase transformer and the load is also connected. If it is a single phase transformer, load is also connected. Alright. Maybe a resistive load, or he has given something load. So even though the core is saturated, what could be the, he is asking which one of the following quantities will not be sinusoidal? Will it be induced EMF? Will you get E1 and E, that is fundamental component and fundamental component, that is primary induced EMF and secondary induced EMF as fundamental components, or otherwise harmonic components also? And then the second question is, which one of the following quantity is non-sinusoidal? Will the flux is non-sinusoidal, load current is non-sinusoidal, or current drawn from the source is non-sinusoidal? Current drawn from the source is generally magnetizing component of current. You can take up that is source current also, primary current also, doesn't matter. Okay, so can you tell me what could be the answer? So generally, like whenever the transformer core is saturated, no doubt the flux is not sinusoidal. The flux is not sinusoidal. So definitely it consists of fundamental component and third harmonic component. If the flux is fundamental component and third harmonic component, induced EMF also fundamental component and third harmonic component. Induced EMF also fundamental component and third harmonic component. Now the third harmonic has a zero, third harmonic EMF can drive the current through this phase. This third harmonic component also can drive the current through this phase. So the induced EMFs on the primary side and secondary side can circulate the third harmonic currents. If the third harmonic currents are going to be circulated, you will get counter third harmonic flux lines. Now this counter third harmonic flux lines will compensate the non-linearities in the magnetic path, and therefore the induced EMF in the windings, will be sinusoidal. E1 and E2 are definitely sinusoidal. E1 and E2 are definitely sinusoidal, no doubt. So induced EMFs are sinusoidal. This is not going to be the answer. Okay. Of course, even if the counter flux is generated, then no doubt the non-linearities are going to be eliminated, and therefore the core flux is also going to be sinusoidal. Here it is highly impossible to get the induced EMF as sinusoidal until unless the flux is sinusoidal. If the flux is sinusoid, then only your induced EMF is sinusoidal. How is it possible to get induced EMF as sinusoid? If you are able to eliminate the harmonics in flux component, then it is possible. Otherwise, not possible, right? Okay. Then the load current. Obviously, load current will be no doubt sinusoidal only because harmonics are eliminated because of compensation. Okay, load current will be sinusoidal. Now here, the only thing is here current drawn from the source. Okay. Why the current drawn from the source is not sinusoidal? Because if you want to establish sinusoidal flux lines in the core, the non-linearities has to be overcome, has to be compensated. So to overcome the non-linearities, current must be non-linear, current must be non-sinusoidal. So this magnetizing component of current must be non-sinusoidal. Generally this waveform is peaky waveform. We say that this waveform is peaky waveform. Okay. If the current wave is peaky waveform, then the flux wave is sinusoidal, and hence the induced EMF is going to be sinusoidal. And that's how you can get the load current also sinusoidal. So the best option is here D. Current drawn from the source is non-sinusoidal. Okay. Is it clear for everyone? Let us move to the next question. Here is a question which is asked here. A 200 volts, 2000 RPM, 10 ampere separately excited DC motor has an armature resistance of 2 ohms. A rated DC voltage is applied to both armature and field windings. He has given that separately excited DC motor. Okay, he has given for armature and for field winding rated voltage he has given. It is asking if the armature draws 5 amperes from the source, the torque developed by the motor is dash Newton meters. What is a torque? Generally, torque equation is what? Torque equation we can say that K phi Ia. As it is separately excited motor, the voltage to the field winding is generally rated. If the voltage is rated, current is rated. If the current is rated, flux is also rated, and you can maintain, generally we maintain the flux as constant. Until unless the voltage is changed, the flux is going to be constant. So you can write the torque is equal to K into Ia. I have armature current that is 5 amperes. So if you can calculate the K value, then it is easy to calculate the torque value. How can you calculate the K value is a question. We have another formula also, that is E is equals to K into phi into omega. Again here the phi is going to be constant, so I can write K is equals to E by omega. We know the speed, we know the speed under no load condition. So under no load condition, or what he has given, rated voltage condition only. Let us take up rated voltage condition. So if I take up rated voltage condition, this is how the induced EMF is going to be. So this voltage, field voltage is going to be rated, and let me write armature resistance as 2 ohms, and here is the back EMF, and the voltage applied to the separately excited motor will be 200 volts. Okay. Now this is drawing 10 amperes and rotating at 2000 rpm, right? The separately excited motor is drawing 10 amperes and rotating at 2000 rpm. So you know current, and can't you calculate back EMF here? Back EMF will be 200 supply voltage minus resistance drop, 10 into 2. You will get 200 minus 20, you will get 180. So I can substitute the EMF here. I can substitute the speed also. The speed will be 2 pi n by 60. So if you can calculate the K from this, it will be 180 divided by 2 into pi into n will be of 2000 rpm. N will be of 2000 rpm divided by 60. So you can write into 60 here. So if you cancel out, or if you calculate, you will get the answer. Can you tell me what could be the answer? 2 into 2000 will be 4000. Let us make 2 zeros, cancel out, and here 40, 18.6 divided by 45. 18 into 6 divided by 40 into 5. So I am getting around the K value as 0.859. This is the K value. There is a K value. Then substitute the K value here, 0.859 into 5. I want the torque at 5 amperes. He is not asking the torque production at 10 amperes. He is asking the torque production at 5 amperes. You just multiply with that respective current, because so until unless there is a change in armature current, there is a change in EMF, there is a change in speed. Okay, you can get it. But this motor constant cannot change, right? This motor constant or machine constant cannot change. So 0.859 into 5, I am getting around 4.29 or 4.3. Approximately 4.3 Newton meters is the answer. This is the answer. Is it clear for everyone? Right. Let us look at next question. Here I have got one more question on series motor. Series motor fed from rated supply voltage is overloaded, and its magnetic circuit is saturated. Okay. The torque speed characteristics of this motor will be approximately represented by which of the following curve? So if it is not overloaded, and the generally magnetic circuit is not going to be saturated. So I can say that generally the torque is proportional to flux and current. As it is series motor, flux is proportional to armature current. So armature current into armature current, you will get armature current square. So the torque versus armature current square graph looks like this actually. The torque versus armature current square graph looks like this. It will be like this, It will be like this, non-linear. Okay. Similarly, he is asking speed versus torque characteristics. Speed versus torque characteristics. Okay. If I take up speed versus torque characteristics, obviously, as the speed versus torque, speed versus torque. If you draw it, you will get like this. Generally, speed versus armature current characteristics will be like this. Speed versus torque also the same way. The moment when the magnetic circuit is going to be saturated, now you will not get much deeper or huge decrement, and the decrement is going to be slightly reduces. So this is how it looks like this. Okay. So he has given the circuit during overload condition only. Overload condition means saturated. The path is saturated. Now, if the path is saturated, the torque is only proportional to armature current. Of course, even the speed is also proportional to speed and this speed torque relations are there. Power is equals to torque into omega. Okay. If I make power as constant, torque is inversely proportional to speed. Or I can write omega is inversely proportional to torque, and I can replace with armature current. The speed is inversely proportional to current. So it slowly decreases like this, probably. Okay. So slight decrement, not a huge decrement, it's a slight decrement. So you cannot expect this kind of waveform, or you cannot expect this kind of waveform. This kind of waveform initially before saturation you will get, and after saturation this B waveform you will get. So the best option could be curve B. Ashok, hi. Very good evening. Welcome to the session. Look at this question. Look at this question. A 400 volts 50 Hz star connected 3-phase squirrel cage induction motor is operated from 400 volts 75 Hz supply. The torque that the motor can now provide while drawing rated current from the supply. Okay. So actually induction motor is rated to operate or designed to operate at 400 volts 50 Hz. But what he's applying? He's applying 400 volts. He's applying 400 volts 75 Hz. The frequency is changed. In fact, he has increased the frequency. So if the frequency increases, what happens to the current? What happens to the current? Did you ask about current? Yeah, rated current from the supply. Rated current from the supply. So what if the frequency increases? Generally, if you look at equivalent circuit, the stator resistance and stator reactance will be there, and of course, rotor resistance R2 dash by S, and similarly, rotor reactance X2 dash. So this is how the equivalent circuit of induction machine. Okay. Now, in this equivalent circuit, the only parameter which depends upon the frequency is reactance. So reactance is X1 is proportional to frequency. X2 dash is also proportional to frequency. What he said, the frequency is increased. If the frequency increases, reactance increases. If the frequency increases, reactance increases. No doubt, if the frequency increases, reactance increases. Then I can say that if the frequency is increased, the impedance offered by this equivalent circuit is going to be increases because it's frequency dependent. Reactance is frequency dependent. If the impedance increases with the same voltage, now what about the current drawn by the motor? Current is equals to V by Z. If the frequency increases, impedance increases, and therefore with the same voltage, that is 400 volts, the current definitely will decrease. Okay. Right. The current is going to be definitely decrease. Very good, Ashok. Look at this question. The rotor of 3-phase 5 kilowatts 400 volts 50 Hz slip ring induction motor is wound for 6 poles, while its stator is wound for 4 poles. Rotor is wound for 6 poles, stator is wound for 4 poles. The approximate average no load steady state speed when this motor is connected to 400 volts 50 Hz supply. 400 volts 50 Hz supply, what could be the best operating speed or approximate average no load speed? Will you get 1500, will you get 500, will you get 1000, or will you get 0? What could be the correct answer? Ashok is saying C. Others also, please try to respond. Stator has 4 poles. Let me mention the poles here: North Pole, South Pole, North Pole, and South Pole. Okay. And let me represent the rotor poles also. If it is a slip ring induction motor or squirrel cage induction motor, generally, if it is a squirrel cage rotor, squirrel cage rotor is just like a bar. Okay, iron bar. Okay, if the stator poles are 4 poles will be induced on that squirrel cage rotor. If the stator poles are 6 poles will be induced on the squirrel cage rotor. Even though the squirrel cage rotor is said to be 6 poles or otherwise 8 poles, if the stator number of poles are 4 poles, squirrel cage rotor will get only equal to stator poles. But when it comes to slip ring rotor, you cannot get the induction of poles like that. Okay. Here he has given it as 6 poles. So let me show you North Pole here, South Pole here, North Pole here, South Pole here, and North Pole here, 3, 4. Na? Okay, let me erase this. North, South, North, South, North, South. So there are 6 poles on the rotor. Now the point is, whenever you give the supply, definitely, the opposite poles tries to attract. Okay. Now this south pole tries to attract it towards the north pole of the stator. If it tries to attract it towards the north pole of the stator, this north pole has to rotate, this south pole has to rotate. Okay, so whenever the south pole is coming under the south pole, it looks like similar poles. If it is a similar poles coming together, you cannot expect the attraction. Instead, you will get repulsion. So this, between this rotor pole and stator pole, you will get a repulsion force like this. The force direction is like this. If the south pole is attracted towards the north pole, but this south pole is repelling from the south pole. So it's not so easy to get a rotation at all. It's not so easy to rotation. It's not so easy to get the rotation. So unequal number of poles will never create in rotation, in the rotation in a particular movement. Alright. Try to understand this point. Unequal number of poles will not give you operation. So the speed of the induction motor will be 0 RPM. Yes, very good, Ashok. So there are some classes, free classes on the BYJU'S exam prep app. Okay, actually started from 11th September, and today we have discussed about use of tertiary winding in the morning. Whenever you find free time, you can just go through it, or you can just download the PDF also, so that you'll understand what I have discussed. Tomorrow morning we will be discussing about the necessity of parallel operation. It's quite same applicable for transformers as well as synchronous generators also. Not just synchronous generator, wherever or whatever the device which you want to put in parallel, there are certain conditions to be satisfied. Okay, generally we operate generators, transformers in parallel. So the conditions or necessity of the parallel operations we will see. Conditions to put the machines in parallel we will also see. And then later, day after tomorrow, we will be looking into some important conceptual problems on parallel operation. So this is the schedule. Every day morning 9:30 a.m. I will be taking the class, and after this, from Monday onwards, 18th September onwards, I will be taking some more topics on DC machines, and the session will be starting at early morning 9 o'clock. Okay, all right. So just give notifications. You don't get notifications. If you don't get notifications, just go through BYJU'S exam prep platform app is there now. Okay, app is there, right? Go to the app and check the free app classes. In that, concept classes or otherwise practice classes. So those are next week it is going to be practice classes. So please look into that. The only thing is, if you don't get notification, please go through the app. All right. Next one. The flux per pole in a synchronous motor with the field circuit on and the stator disconnected from the supply, is found to be 25 milliwebers. Field circuit, that is excitation is on, but stator supply is disconnected, that is armature current is 0. Now he said that if the stator supply is disconnected, then the flux is found to be 25 milliwebers. Now, when the stator is connected to the rated supply with the field excitation unchanged, the flux per pole in the machine is found to be 20 milliwebers. Okay. While the motor is running on no load, assuming no load losses to be 0, the no load current drawn by the motor from the supply is. Okay. It's like first case is there is no supply to the stator winding, and the second case is there is a supply to the stator winding. So let me show you here this is my stator supply and the supply is not connected. So this is my three-phase supply, no connection. So I can say that armature current is 0. If armature current is 0, armature flux is also 0, no? If armature current is 0, armature flux is 0. He said only the field circuit is on. If the field circuit is on, let me take up salient pole rotor. If the field circuit is on, I can say that only main field flux is going to be existed. Okay. Generally, in the machine, the net flux is going to be, resultant flux or net flux is going to be main field flux plus or minus armature flux. Here the armature flux is 0. Main field flux we do not know. And net flux, he said, the net flux or the net flux per pole is found to be 25 milliwebers. So I can say that when the stator is not connected to the supply, the air gap flux is equivalent to main field flux, that is 25 milliwebers. Now he is going to connect the supply. So let us connect the supply. Give the supply. Okay. So if you give the supply, then armature current flows, IA is not equal to 0, then armature flux is not equal to 0. The excitation is not changed. If the excitation is not changed, the main field flux is going to be still the same, right? Main field flux is going to be still the same, that is 25 milliwebers. Okay. Now the net flux is what? Net flux is phi m plus or minus phi a. Main field flux is 25 milliwebers, and we do not know armature flux how much is going to be, but he said that the flux per pole in the machine is found to be 20 milliwebers. Okay. So if you want to get 20 milliwebers, what must be the armature flux? What must be the armature flux? This armature flux must be negative 5 milliwebers, so that 25 minus 5 you will get 20 milliwebers now. That means what I can say is this is no load only. We did not keep any load. Okay. This is no load only. So under no load, the armature flux is opposing the main field flux. If the armature flux is opposing the main field flux, I can say that this armature reaction is demagnetizing effect of armature reaction. This armature reaction is demagnetizing effect of armature reaction. Okay. If this is demagnetizing effect of armature reaction, what could be the power factor? Leading power factor, na? Leading power factor. The no load power factor will be leading power factor. For synchronous generator, if demagnetizing effect of armature reaction is going on, the power factor is lagging power factor. For synchronous motor, it is quite opposite, leading power factor. Voice is not clear. Is it clear now, Ashok? Is it clear now? Okay. Right. Look at this question. It is desired to measure the parameters of 230 by 115 volts 2 kVA single phase transformer. The following wattmeters are available in the laboratory. So he has given some wattmeters and is asking the wattmeters used in open circuit test and short circuit test of the transformer will be. Open circuit test and short circuit test of the transformer. If you want to perform open circuit test, what should be the wattmeter? The wattmeter must be low power factor wattmeter. If you want to perform short circuit test, the wattmeter would be unity power factor wattmeter, otherwise high power factor wattmeter. So out of the 4, you can choose one as low, another one as low power factor wattmeter. One is going to be low power factor wattmeter, another one is going to be high power factor wattmeter. Okay. So if you want to choose this one, generally in open circuit, the no load current drawn by the open circuit test or open circuit condition will be very small. Under no load condition, the no load current is going to be very, very small. Generally, that is no load current is around 5% of full load current. Can you tell me what is a full load current on a no load? The 5% of full load current. The full load current is generally taken as power rating. Power rating divided by voltage rating. That is 2000 VA divided by voltage rating. We will conduct the open circuit test on LV side, not HV side. So I am taking 115. So how much you will get? 2000 by 115. Or let me cancel out this Z 0000. So 100 divided by 115. I am getting around 0.86. It is not even 1 ampere. So you should select a low power factor wattmeter with less current range. So this is a low power factor wattmeter with a 10 amperes range. But don't we require this one? No need, na? Because the current, no load current is just hardly 1 ampere. So to measure 1 ampere, don't take a large range, current coil range. Okay. So the best option is W2. The best option is W2. Okay. Similarly, you have to do it for short circuit test. For short circuit test, what is the rated current? Generally, the rated current is, you can mention the rated current on high voltage side will be 2000 divided by 230. So probably if it is 120 by 2, it is 100. Okay, 20 10 less than 10 amperes you will get. Probably less than 10 amperes. So 200 divided by 23 amperes. I am getting around 8.69. 8.69 is greater than 5 amperes now. So you cannot take up 5 amperes range current coil. Okay, you cannot take up 5 amperes range current coil. We can go ahead with a greater than 5 amperes range current coil. So you can go with 10 amperes range current coil. This is pressure coil voltage range, VPC, and this is current coil range, current range in the wattmeter. So W2 and W3 are best preferable wattmeters to perform the open circuit test and short circuit test respectively. This is for open circuit test and this is for short circuit test. Is it clear for everyone? Very good, Ashok. I request everybody to answer the questions. So far we have seen some questions and the questions are not much tough. Questions are moderate and easy only. Okay, until unless the question is very lengthy. There are some questions which are lengthy also. So you can't get that lengthy questions, once or twice, and that too one question hardly. So you will not get that kind of very lengthy questions every year. Let us look at this question. A 400 volts 50 Hz 30 Hz 3-phase induction motor is drawing 50 amperes current at 0.8 power factor lagging. The stator and rotor copper losses are 1.5 kilowatts and 900 watts respectively. Stator and rotor copper losses. Okay. The friction and windage losses are 1050 watts and core losses are 1200 watts. Now the air gap power of the motor is asking. Air gap power of the motor is asking. So if you want to find out air gap power, you should have an idea about the power flow diagram, right? You should have an idea about the power flow diagram. So if you look at power flow diagram, this is going to be motor input, or I can say is PSI, stator input. After giving the input to the stator armature winding, then definitely there will be some drop, right? Definitely there will be some drop. That is stator iron losses and stator copper losses. Stator iron losses plus stator copper losses. Okay. And then the remaining power is called as air gap power or otherwise rotor input. Once the rotor is going to receive the power, you will get some copper losses, that is rotor copper losses. You can also have rotor iron losses, but generally we don't consider rotor iron losses because the rotor frequency is very small. As a rotor frequency is 1 Hz or 2 Hz, the rotor iron losses, that is so called hysteresis loss and eddy current losses in the rotor, will be very small because the frequency itself very small. But for the stator frequency, it is 50 Hz supply frequency. Rotor frequency, it is just 1 Hz or 2 Hz. So from the rotor input, if some copper losses are going to be lost, then the remaining power we call it as gross mechanical power. And the next losses are going to be friction and windage losses, that we can write it as mechanical losses. And the remaining output power is going to be shaft power. Shaft power. So he has given some rotor copper losses and stator copper losses. Stator copper losses as 1.5 kilowatts. What I can say is 1500, and rotor copper losses as around 900 watts. He did not mention stator copper losses separately, right? He just mentioned only the stator and rotor copper losses. Okay, fine. Fine. He has mentioned the friction and windage losses. He has mentioned the core losses. Okay. First one he has given it as like this. Stator and rotor copper losses he has mentioned as 1.5 kilowatt and 900 watts. So stator copper losses as 1.5 kilowatts. Rotor copper losses as 900. And at the last he has given core losses as 1200. So this is 1200 watts. Now he is asking air gap power. Air gap power. What is the air gap power? Air gap power is going to be, rotor input power is going to be stator input power minus losses. Now, stator losses. Stator input power, how do you calculate? The voltage is there, current is there, and power factor is also there. There is a line voltage, line current you can take up. So stator input power will be √3 into VL into IL into power factor 0.8. Okay, 400 into 50 into 0.8 into √3. So I am getting around 27.712 kilowatts. This is the stator input. This is the motor input drawn. There is an input drawn from by the motor. Okay. Now out of this you can deduct the losses. Now stator losses. What are the stator losses? 1200 plus 1500, 2700. Now, so rotor input power is equals to 27,712 minus 2700. So you will get it as 25.012 kilowatts. I am getting C. I am getting C. Please check from your side also. All right. Okay, no issues. Achok. So I have one more question here. A 230 volts 50 Hz 4-pole single phase induction motor is rotating in the clockwise direction or forward direction at a speed of 1425 rpm. If the rotor resistance at standstill is 7.8 ohms, then the effective rotor resistance in the backward branch is forward branch with forward slip, backward branch with backward slip. Generally, resistance has to be divided. Now, R2 dash by AC is the total resistance, total rotor resistance, and it must be divided. It must be divided for forward direction half and reverse direction half. So I can write R2 dash by S by 2 and R2 dash by S by 2. If it is forward direction, represent forward slip. If it is backward direction, represent backward slip. He is asking backward branch. So the backward branch, generally backward slip is going to be NS plus NR by NS you will get, not NS minus NR. So if you solve that, you will get it as 2 minus forward slip. Okay. I have the standstill equivalent resistance. Standstill means at slip equal to 1. At slip equals to 1. Okay, so now the backward branch R2 dash in the backward branch is going to be R2 dash, that is 7.8 divided by 2 into backward slip, that is 2 minus ES. So you'll get 7 and 7.8 by 2 is going to be 3.5 or greater than 3.5, and of course 2 minus S. What is the S value? Slip value. Slip SF forward slip value is going to be synchronous speed minus rotor speed. Rotor speed here it is 1425. Synchronous speed will be definitely 1500. Because it is 4 pole na, 1500, no doubt. Generally Induction motor rotates near to the synchronous speed. So 1500 minus 1425 divided by 1500, you will get it as this one as 75 divided by 1500. I am getting around 0.05, slip as around 0.05. So if I substitute this slip 0.05, 2 into 2 minus 0.05 will be 1.95, and this is 7.8. So 1.95 into 2, 7.8 divided by answer. I am getting around 2 ohms. Is it so? Is this the answer? 2 ohms, is this the answer? I am getting 2 ohms. Okay, done. Look at this question. Distributed winding comma short. What I can say, it should be actually distributed comma short pitched winding, because distributed winding, short pitched winding is a classification of distributed winding. So you cannot write distributed winding comma short pitched winding. It should be actually distributed short pitched winding. Distributed short pitched winding is employed in AC machines will result in. Generally, distribution winding is to get sinusoidal, is to get near to sinusoidal waveform, right? Sinusoidal waveform. And short pitched winding we employ in this sinusoidal waveform. If you have any harmonics, that has to be overcome to eliminate harmonics. So if you use distributed short pitched winding, there is no doubt harmonics are going to be eliminated. Okay, reduction in EMF, increase in harmonics. No, this could not be the answer. Reduction in harmonics could be the answer. Increase in EMF and harmonics, no, could not be the answer. Reduction in both EMF and harmonics. First option is increase in EMFs. Last option is reduction in EMF also. Harmonics are going to be eliminated with the help of short pitched winding. And I want to tell you, even EMF also going to be reduced, because induced EMF is proportional to Kp and Kd, na? Kp and Kd. So what is Kp? Kp is equals to cos alpha by 2. If the short pitched angle increases, then cos value will decrease. If the cos value decreases, Kp decreases. If the Kp decreases, EMF also decreases. So if we use short pitched winding, definitely no doubt the induced EMF magnitude will decrease. The induced EMF magnitude will decrease. A is not the correct answer. Correct answer is reduction in both EMF and harmonics. D is the correct answer. Okay, you should include 2 also, because backward branch, forward branch resistance has to be made equally. Half, divided equally. Here there is an announcement about the scholarship test. The scholarship test will be conducted on 17th September, 9 AM to 9 PM. So, like, if you want to enroll with the BYJU'S exam prep platform, you can write the scholarship test so that you can get the discount up to, or concession up to 90% on the actual fees. Okay, right. So try to attempt the scholarship test. And there is one workshop which is going to be taken by Abhinav sir. Okay. On 20th September, 7:30 PM. So the workshop is about how to get 80 marks in GATE. How to get 80 marks in GATE with 75% syllabus. Okay. Look at this question. A single phase 400 volts 50 Hz transformer has an iron loss of 5000 watts at the rated condition. Rated condition means 400 volts 50 Hz condition only. When operated at 200 volts 25 Hz, that means what, voltage is reduced half and frequency also reduced half. The iron loss is found to be 2000 watts. When operated at 416 volts 52 Hz, now the voltage is increased more than the first case. Frequency also increased more than the first case. The value of hysteresis loss divided by the eddy current loss is going to be how much? The value of hysteresis loss divided by eddy current loss is going to be how much? Okay, that is what is asking. So you need to take up the equation, iron losses equation. Separation of iron losses into hysteresis loss and eddy current loss. A times F plus B times F square is equal to iron losses. Wi by frequency is equal to A plus B times F. So that formula, use that formula, you will get it. Look at this one. So here 400 by 50, if you want to find out iron losses, check the voltage to frequency ratio. 400 by 50, this comes out to be 8. 200 by 25, this also comes out to be 8. And similarly 416 divided by 52, this also comes out to be same constant. 452 or 416, yeah, 416 divided by 52, again you will be getting 8. So the voltage to frequency ratio is maintained as constant, so flux density is maintained as constant, and hence the hysteresis loss are directly proportional to frequency and eddy current loss are directly proportional to frequency square. When you add up them, the iron losses are is equals to hysteresis losses plus eddy current losses. So this proportionality constant I have written it as A, this proportionality constant I have written it as B. If you take up frequency as common, Wi by F is equals to A plus B times F. Okay. So we have first case, second case and third case. We have two cases now. From that you can calculate. Iron loss is going to be 5000 watts on 50 Hz case. A times B, sorry, A plus B times F. F is going to be 50. Now second case, we have got 2000 watts of iron losses at 25 Hz is equals to A plus B times 25. So you can solve this equation by changing the signs. If you change the signs, A can be cancelled and you will get it as B25 or 25B. 25B is equals to 5000 by 50, it comes out as 100. 2000 by 25, oh, how much? 2000 by 25, 25 4s 100, 25 8s. 2000 by 25, 8s, 80. So this comes out to be 80. 100 minus 80 will be 20. So B value is equals to 5 4s 5 5s, 0.8. B value is 0.8. Now can't you calculate A value? If you substitute B value, then A value is how much? B 0.8 times 50, or let me write 0.8 times 50 equal to 40. 100 minus 40. I'm getting 60. Is it so? Very large value. A value. A value is very large? If B is 0.8, A value I am getting it as 100 minus 0.8 times 50. Now 40. 100 minus 40. 60 I am getting. A value I am getting 60. Now what is asking? He is asking, when operated at 416 volts 52 hertz, what is the value of hysteresis losses divided by eddy current loss? Hysteresis loss is going to be A times F, na? That is 60 times F. F is 52. So you will get it as 60 times 52. I am getting it as 3120 watts. What about eddy current losses? B times F square, na? B is 0.8. F is 52 whole square. So 52 square into 0.8. Now I am getting it as 2163.2 watts. Now you need the division of hysteresis losses or the ratio of hysteresis losses to the eddy current losses. 3120 by 2163.2. So the ratio I am getting it as around 1.44. 1.44. Very good. Ashok, is it clear for everyone? Right. So look at this one. There is a single phase 22 kVA, 2200 by 220 volts 50 hertz transformer, distribution transformer, is to be connected as an auto transformer. So it's a 2-winding transformer. You want to reconfigure as an auto transformer to get an output voltage of 2420. 2420 is possible when you add high voltage winding plus low voltage winding voltages. Now, so its maximum kVA rating is dash. So it will be like this, right? So this is what 2200 high voltage winding we will give, and the low voltage winding is of 220. So you will get 2420 volts. This is the output voltage, secondary voltage. What is the rating now? How would you take up rating? Rating will be taken in terms of voltage into current. I know the voltage, that is 2420. What is the current carrying capacity? Or what is the current which will be delivered to the load? If you want to find out the current which is delivered to the load, you must know the current carrying capacity of this 220 volts low voltage winding. The current carrying capacity of low voltage winding is going to be 22 kVA, 22,000 divided by 220. So it comes out to be 100, right? It comes out to be 100, right? 22 kVA means 22,000. So it comes out to be 00 can be cancelled and 2200. So this winding can deliver a current of 100 amperes. So we have a voltage of 2420 and a current of 100. Now what will be the kVA, possible kVA? 2420 into 100. It's like 242 kVA. 2-winding transformer kVA rating is just 22 kVA, and if you just reconfigure the same transformer as an auto transformer, you are getting huge amount of kVA, that is 242. Where is 22? Where is 242? It's 200, na? 200 greater, almost 200 kVA greater. So 242 kVA could be the answer. C is the answer. Is it clear for everyone? Same kind of question asked in 2016 also. You can look into that. 2 kVA 100 by 200 volts transformer is reconnected as an auto transformer such that its kVA rating is maximum. So if you are expecting maximum kVA, generally the high voltage winding should be connected as common, 200, and the low voltage winding must be connected in series additive manner. So we give the supply here and we take the supply from this. So the terminal voltage or secondary voltage is what now? 200 plus 100, it will be 300. Now if you can find out the current carrying capacity of the low voltage winding, that's fine. The current carrying capacity of low voltage winding is power rating, that is 2000 divided by 100. You'll get it as 20 amperes. So what is the load kVA now? What is the kVA now? 300 into 20. 300 into 20. So it will be 6000 or otherwise 6 kVA. 6 kVA is answer. 2 winding transformer kVA is 2 kVA. Now if you reconfigure it, you are getting 6 kVA. Okay, is that clear? So likewise, there are some questions. I think you can transfer this secondary parameters onto the primary side. Then he's asking port 1 equivalent circuit. If you transfer, it will be generally L by K square. K is of what? Transformation ratio 1 by N. So it will be 1 by N square. It comes out to be 1 by N whole square, or N square L you will get. So this kind of questions are there. Please try to look into these questions. Okay. Try to look into these questions, very simple questions only. Some questions are lengthy and some questions are, takes easy, less time. Okay. So there is a crash course announcement from the BYJU'S exam prep platform for EC and EE also, for all the branches. For all branches. If any one of your friends are joining or wants to join, then please refer them. Okay. So the advantage with the BYJU'S exam prep platform is you can write the test series and you can find out your score accurately and you can compare. Okay. So there are some other questions also on DC machines like this. Induction machine, DC machines, single phase induction machine. Please look into them. So the questions are out of 100%, I can say questions prepared by IISc Bangalore is not tough. Okay, don't say that, don't think like that. Not just IISc Bangalore, let it be any IIT also, they will try to prepare the question paper as a mixture, easy, moderate and tough. So the tough questions are of very few. Out of, if machines, if you are getting around 5 to 6 questions, out of 5 to 6 questions, hardly 1 or 2 questions will be very lengthy questions. Remaining questions will be easy. So don't be in such a state of mind that IISc Bangalore is going to prepare paper and it is going to be very tough. Even the organizing committee is going to be IISc Bangalore, but the paper will be set by the all professors. The professor from IIT Bombay, the professor from IIT Madras, the professor from IIT Kanpur, the professor from IIT Kharagpur, okay, the professor from IIT Delhi, they are going to set up the paper. Okay. So don't think that the paper is going to be tough. Okay. So once again, this is my Telegram channel. If you have any doubts, you can reach me so that I'll try to help you. So there are some other questions also. Please look into it and you'll get the answer. That's it. Thank you. Thank you so much. Have a nice day. Okay. If you have any questions, you can ask me. All right, then we'll end up the session here. Okay. Bye.